If you think about it, applications that you create using Windows Forms really don't show off well. They're just ugly. Sorry. Applications require now sort of a new way to present information. Rather than just rectangular forms, charts, and graphics, well, sure, business applications can probably get away with that. But commercial applications or applications that you want to pop, to really look like something, need something more than standard Windows Forms rectangular forms. That's the best you're going to get with the Windows Forms application. You have the rectangular form, you got your rectangular controls. You can modify this to some bit, but you really don't have enough control over it without writing a whole lot of code to make it look significantly different. Let's pop out for a moment and look at a WPF application and see how it compares to the standard rectangular gray forms. This application is a reference application written for Microsoft by a company, Vertigo Software, that shows off some of the features of WPF. We'll look at it in a little more detail in just a bit, but you can see it really doesn't look like a standard Windows Forms application. We have these pop-up things that don't look like standard controls, forms that pop in and out, scrolling that works smoothly, scaling that works nicely, and so on. This clearly is not a Windows Forms application. It might be possible to create something like this with Windows Forms, but good grief, it'd be a lot of effort. You might ask yourself, what's wrong with what we have? What's wrong with Windows Forms? Well, existing Windows graphics techniques make it difficult to create visually appealing applications. Up until recently, let's face it, graphics hardware just wasn't powerful enough in general for anything fancier than Windows Forms. Well, sure, gamers had fancy graphics, but for standard business applications, you had to spend a lot of money to get something that was fancier than Windows Forms and have it look decent. You could create these movie-style interfaces if you'd like with Windows Forms, but it's difficult, and each application then requires its own set of tools. If you want 3D graphics, you need external libraries. Standard Windows GDI and user libraries, that is the standard built-in graphics libraries that have been there since Windows first started, are extremely limited. Windows Presentation Foundation, WPF, provides a new medium for creating applications. It takes advantage of whatever hardware power you have and provides a consistent, powerful graphics platform for building applications. Let's look at what WPF provides. It has an integrated, vector-based composition engine as opposed to pixel-based, which is how Windows generally draws things. It utilizes the power of the PC throughout the graphics stack, so the more power you have, the better rendering you get. You also get resolution independence, so you can create your applications at one resolution and have them look decent at a different resolution. It provides a unified approach to UI, to documents, and to media. That is, WPF provides a way to scale graphics, to draw text, to display documents, to display music and video, all within the same API and application. Integration is just part of that development experience. Everything fits together neatly using WPF. WPF also provides declarative programming. This is XAML, X-A-M-L, that you may have heard about. It brings designers directly into application development. That is, you can split the design portion of your application from the coding portion of your application because declarative programming makes it so that different tools can work with the same design output. You can have Visual Studio working on a project and Microsoft Expression working on the same project, sharing the same underlying code, but different tools work better for different applications, and some people like working with Visual Studio, others like working better with visual designers like Expression. It allows you to separate the design and the code so multiple people can work on the same project at the same time. It allows for ease of deployment, allows administrators to deploy and manage applications securely. Now, if you're working with WPF, you care about how graphics work. WPF includes modern graphics capabilities, both two-dimensional and 3-dimensional graphics. Windows Forms supported 2-dimensional graphics fine. You'd have to fight hard to get 3-dimensional graphics to work in a Windows Forms application. It supports image effects, that is, moving images around, scaling, rotating, transforming images, and multiple codecs for displaying those images. It supports hardware-accelerated sub-pixel clear type, so you get very neat and clear text displayed on the screen. You also get full audio and video support built directly into the API and into your programming environments. Before we move on, we should think about some important questions that you might have. First of all, does WPF allow me to do something I couldn't do before? What do you think the answer is? Yes? No? The answer is no. Really, everything you can do in WPF you could have done before. It's just all about how much effort you want to put into achieving these results. It's a lot easier in WPF to do the same kinds of things that would have been difficult in Windows Forms. Should I use WPF instead of DirectX? Well, really, that's a difficult choice. For hardcore games, programming DirectX directly might be a better choice. On the other hand, you can always combine WPF and DirectX in the same application using WPF for your UI and DirectX programming directly for cases where you really need the features that gaming DirectX requires. Here's the important one. Should I just drop Windows Forms and start using WPF now instead? That's debatable. I don't think anyone would say at this moment in time that you should just give up on Windows Forms. They're fully supported in Visual Studio 2008. There are some new features, not too much. But WPF is new in Visual Studio 2008. Visual Studio provides a similar set of controls for each, although data binding in Windows Forms is far easier to visually take care of than in WPF. On the other hand, data binding is richer in WPF than in Windows Forms. WPF makes it easier to create rich media-centric applications. Windows Forms, it takes a little more effort. Oh, and one last thing. If you need Windows 98 support for your application, and for your sake I hope you don't, but if you do, you can't use WPF because it's not supported on Windows 98. That platform has lost support at Microsoft. So if you need support for that platform, it ain't going to happen right now. Should I use WPF instead of Adobe Flash? Well, there's an interesting concept. For web-based applications, Flash, at least at this point, is currently the standard for displaying media. WPF becomes viable for web-based competition with Flash once Silverlight, which is due out after the release of Visual Studio, becomes a real product. It's getting there. Silverlight actually released already. There is no support for Silverlight in Visual Studio, no special support anyway, and Silverlight is still a product in development. It isn't final yet. Once it is, however, it really competes well with Adobe Flash. Silverlight provides a small WPF runtime that supports XAML, that is the declarative markup language for WPF, and JavaScript, which is perfect for rich browser-based applications. You'll see Silverlight used more and more on public websites. At this, you don't see it much except on Microsoft's website and developers who are early adopters who want to use it on their own websites. For public websites, the big public websites, not yet. But over time, it will become a reasonable replacement for Flash. Microsoft has commissioned a reference application, you already saw it for a few seconds, named family.show. This application uses WPF and demonstrates how you might use WPF in your own applications. The source code and the application are available for download at the CodePlex site. If you browse to codeplex.com/family-show, you can download the entire application and play with it. It includes full source code and documentation about the design of the application. It includes, for demonstration purposes, a truncated family tree for the British royal family, which goes back centuries. Of course, they couldn't get it all in this demonstration. You can easily, to play with it, create your own family tree. If you go to the website, you'll also see some videos and documentation on genealogy studies and programs in general, which I think the company that created this spent a lot of time studying to create a real genealogical application. The application provides a rich visual representation which would be difficult to create without WPF. We'll investigate the zooming and panning features and also look at different views of information to see how you can use WPF to display things in different or original sorts of ways. Let's look at family.show and see how you can use it as an educational tool to learn more about WPF. In Windows, I'll start the family.show application. There it is. Now watch carefully once I click this link. What you'll see is that this is a click once application. There it is, indicating that it's verifying application requirements. If there was a new version available on their website, it would have downloaded and installed that version now. So that proves that click once and WPF work well together. Let's maximize this thing and let's open, well, I've already been investigating the British royal family. So I've opened this before, I'll open it again. You can see here a representation, a visual representation of the British royal family. I can zoom out here and see more of the data, or zoom in. And notice as I zoom in, the text doesn't get all big and chunky. It actually looks better as you get bigger and bigger and bigger. This is one of the features of WPF. It scales the text for you. Rather than doing it on a pixel by pixel basis, this is vector-based text. So as you scale it up, it just looks better. I can also scroll this data around easily. Let me click and drag. I may have to make it smaller to do that. It's too big. There we are. We can click and drag and scroll this around, and it does it very smoothly, as you can see. We can also use this slider to zoom out and remove or gray out various members of the royal family. That's easier to see if I zoom out farther. You can see by dates who was alive at that time. And that's a nice effect. Sure, you could do it in a Windows application, a Windows Forms application, be a lot harder. Here we have a splitter that works very smoothly. And we can also pop up various forms to get information about people, details, etc. If I had a little more room on the screen, clearly they didn't plan on people with this screen resolution running this application. Let's choose someone, say here, and there we see information about that particular person. We can also look at relations between people by adding these lines that connect them, and so we could, for example, delete someone, there we go, and just remove them from the chart, and everything reorganizes to make up for that. Well, clearly there's a lot to this application. One thing I will point out is there is a standard for genealogical information, the GEDCOM standard, and you can import existing genealogical data. So if you have already used another application to chart your own genealogy, if you have an application that uses this same standard, you should be able to import the file into this application. For example, let's not save this one. This application comes with the Kennedy family, a very small version of their family tree stored in the GED format from another application. We can load it up. There we are. And see if we zoom in a portion of the Kennedy family tree. For example, Joseph Kennedy, and down here Peter Lawford, and so on in this application. Sort of interesting how they've used WPF here to draw different images for different people, to incorporate images. We don't have a picture of Victoria Lawford, but we could, and so on in this application. Certainly, no one would disagree this looks different than a Windows Forms application. You look at this and you know it's done with something different, and you look at a few WPF applications and they start to look, sort of have telltale signs that it's done with WPF, and one of them is the scaling and the panning that is so easy to do in WPF. Before you jump off the Windows Forms bandwagon and just say, I'm using WPF, there's some things you should consider. It's far more difficult to create a decent-looking application in WPF than it is in Windows Forms. The tools aren't as good, they're not as mature. The bar is just lower in Windows Forms. No one expects them to look very good. I would find it absolutely impossible to create that family.show application on my own because I am not a designer. I write code, I can't create user interfaces. Developers creating applications in WPF, like me and perhaps like you, generally create ugly applications. A good WPF application requires a graphic designer. End of story. Believe me, you have to have a designer to lay out what you want this thing to look like, or otherwise it's going to look like a Windows Forms application and you might as well use Windows Forms. On the other hand, it's far easier to create great-looking applications in WPF than it is in Windows Forms. It's difficult to create a great-looking application in Windows Forms, but if you have a designer and good coders, it's a lot easier to do it in WPF. Windows Forms are just too limited to create fancy, elegant, rich-looking applications. I will mention that you should also check out Microsoft Expression Studio, a separate product that's useful for designers to use when designing user interfaces. It doesn't really support much in the way of code. Visual Studio does that nicely, and Expression and Visual Studio can coexist very nicely working on the same project. On the other hand, Visual Studio has very rudimentary design tools, as you'll see as we start working with creating WPF applications in Visual Studio. If you've heard about WPF, you've probably also heard about XAML. Are they the same thing? What is XAML? Well, XAML is an XML-based grammar. It declaratively defines WPF applications. Windows Forms, think back, is just a set of classes. The deal is WPF2 is a set of classes. There are classes in the .NET framework that make up every WPF control, every WPF property is a property that's defined in the .NET framework. In Windows Forms applications, you have to write code to generate the interface. Well, you can drag and drop controls onto the designer, but then the designer writes code, real C# or VB code, that generates the interface. If you've ever examined a Windows form and its various classes, you've seen that. For WPF, you can either write the code in just the way that you would write the code for Windows Forms, create a new instance of a class, you set its properties, and so on, or you can write XAML. XAML is declarative. You lay out XML that defines attributes that have the properties of all the controls. Makes it a little easier to see exactly what's going on. I will point out that XAML to WPF isn't a one-to-one mapping. That is, there are classes in WPF that have different names than the corresponding elements in XAML, and you get good after a while of recognizing those differences. Some names in XAML don't match the same member names in WPF classes. Most of the time, they do. Visual Studio 2008 provides several different templates for creating WPF applications. There's the standard WPF application. That's the Windows application using WPF. There's a WPF browser application. That's for creating applications that run in a browser using WPF. There's a WPF custom control library. Now, this custom control library allows you to use Windows Forms controls as well as WPF controls. And there's a WPF user control library in which you create new WPF controls. Now, in our demo later in the course, we will create a new user control for WPF. We won't put it in a separate library, although we could. It just complicates the demonstration. But you generally can create libraries of WPF controls if that's what you need to do. For this demonstration, we'll focus on creating a Windows-based WPF application, so we'll use the standard WPF application template in Visual Studio. Let's just jump into Visual Studio and give it a try. In Visual Studio, I'll create a new project, and I'll choose Visual C#, Windows Projects, and I'll choose a WPF application. I don't really care what it's called, although I think I'll call it WPF Intro, just so I know what it's called. I'll click OK to create the project, and Visual Studio creates our project, including window1.xaml and window1.xaml.cs. We'll put code in this file and XAML markup in this file. There's also an app.xaml file, which contains markup that pertains to the entire application. We don't need to look in there now, but any settings or resources you need that apply to the entire application, you'd put there. Notice that here we have a design pane and a XAML pane. Up here we see a visual layout, and down here we see the markup. In addition, there's also a properties window here, and we can change properties either here, or here, or here, and they'll update accordingly no matter where we make the changes. The main window element here corresponds to this whole window, and within that window, the designer assumes that you want a grid. There's our grid control that defines the layout for everything in the window. You can change that. You don't have to have a grid. You can delete it and start with something else if you want. For now, we'll just use that grid. Now let's look at some of the features of the layout of Visual Studio here. Now we have these little icons here which allow us to control how this window is split. If you want a vertical split, if that works better for you, you can do vertical or horizontal. You can close the XAML window if you want and only see the design window, no matter how you want to do it. You can swap the windows, and now you can close the design window and only see the XAML window. We can swap them back. In the design pane, you'll also see this zoom slider. Lets you zoom in on your design all the way out. You can also click this button, which says to have the design fit as best it can in the space you have. There we are. So we can either show it reasonably full screen or zoom to fit. Now let's look at the XAML we have here. The window element defines the behavior for the entire page. Now it's important to note these two namespaces here. The default namespace for all of this XAML is, well, it's a big long string here. And a namespace is just a way to define a group of things that all go together. So the default for all of those is this namespace. There's also a second namespace named X. That's the abbreviation we'll use, which corresponds to a different namespace. Now, what does this all mean? Well, these namespaces in the XAML correspond to one or more .NET Framework namespaces. This namespace, for example, the XAML/presentation, corresponds to namespaces in .NET, which provide the controls and the features, the layout features of your design and user interface. The X namespace here, the one named XAML, provides information about events and other programmatic entities. So when we need to refer to one of those, like a class, we need to tell our code that it's coming from this particular namespace, and you can see right here that the class that tells the code, the XAML, where to look for event handlers, that attribute is defined with the X: prefix, indicating that it's a programming sort of thing. If you see things without a prefix, like grid or window, those are coming from this namespace, and those are user interface kinds of things. Generally, you don't have to worry about the difference. Generally, the designer will insert the X or not or any other namespace as you need it. IntelliSense is pretty good here in the XAML designer. Okay, for the main window, we have a title attribute, which defines the title we see here. There's a height and a width attribute as well. And like I mentioned, the grid element acts as a container for the contents of this form. Okay, well, let's look at the properties window. If I click the window element and come over here, you can see that we're working with the window. I can even set the name of this window if I want, and I'll set this to main window. When I do that, we now have a new attribute, main window here. The only reason you have to set the name is if you programmatically want to refer to that window from code somewhere. I don't really need to, so I'll remove that for now. Okay, we don't need that. What I do want to do is change the title, however. I can change the title here, and let's change it to Hello WPF. And you'll see that changes it both here and here. I can also change that title here, for example, and that changes it here and here. So everybody attempts to communicate. Now, I will mention that sometimes you'll get a message telling you need to refresh the designer. Just click the link. it'll fix things up for you. Let's put some controls on here. Let me show the toolbox window, which right now shows nothing at all. Why is that? You need to click in the design surface so the toolbox knows to display controls for WPF forms. So I'll put a button from the common selection onto my grid. Let's look at its properties. I'll hide that window for now. Let's make this a little bigger. And we can see here, here's our button element that defines the behavior of this button. I actually need a little more space for this, so let's wrap the XAML code instead. There we go. You can see, for example, that the height currently is 23. If I change the height, it gets bigger and bigger. Now it fixes up the height here. You can even see indicators on the right here. See that little red 35? Now that height goes over here. Now watch this. Notice they don't specify the width or any of the other features. They use margin instead. So at this point, margin is 83 from the left, 32 from the top. Well, let's see what happens if I move the button around. Those values obviously change. If I remove this margin attribute altogether, in that case, the designer assumes you want the button to fill all the available space, but we have the height set to 35. Let's remove the height. At this point, removing the height, well, there's still more problems because it's set the vertical alignment at the top. I don't want a vertical alignment. I just want it to fill the entire space. There we go. If you don't specify a margin and you don't specify any of the other properties, if you just put the name, you get a button that fills its entire container. I can change the content of this button, say to click me, and then that's the text that appears within the button. Now here I could also set the margin to a single value. Let's set it to 5, say. Now we have a 5-pixel margin around the edge. So if you only specify one value, it uses that same value around the entire border. If you specify nothing at all, it assumes you want a margin of 0. In addition, this click me here is really just a representation of the content attribute. So if I make the content be click me, it's the same as putting click me here. But you can't set the content more than once. You either set it here or you set it here. If all you want to do with the button is display text, it's easiest just to make it be the value of the button element so it displays within the button. Now, I won't mention this every time, but every attribute we set here, we can also set over here. The problem I have is that you don't get IntelliSense for every property over here, and you do over here. And in addition, these things aren't alphabetical. There's no way to sort these alphabetically, so it's often difficult to find the property you want. I find it easier here just to use IntelliSense to look at the various properties and see what's available. These, at least, are alphabetical. So it's really up to you how you set the properties of your controls in WPF. You can either do it in the XAML or in the Properties window. Now, clearly, there are more properties that WPF provides than we could ever cover in a course like this. So we'll just focus on a few of the properties to demonstrate the WPF behavior. Maybe I want to be able to click this button and have something happen. Before I do that, let me give this a name that I can remember. Okay, set the name the demo button. I could also set that over here. Let's double click and see what happens. Well, just as in a Windows Forms application, it takes you to the code behind class for this form, allowing you to type code in reaction to the click event of that button. And I'll put some code in here. Messagebox.show, hello from WPF. Okay, let's see what else we got here. Well, if we go back to the designer now, what you'll see is there is now a click attribute defined which refers to that procedure. I can right-click, and one of the options is navigate to the event handler, so I can get to any event handler in just that way. Well, let's save it and run it. And you'll see your first WPF application running. There's our button. We click it. Oh boy, it worked. You have to do the standard Hello World application in every environment you start programming in just to see how the events hook up, how the controls work, and so on. Well, let's go back and play with this some more. here in our designer, you're going to see this in your own application sooner or later. It says we have to reload the designer. Click here to reload. You click, they reload the designer, and everybody's happy again. It's going to happen to you. Just be ready for that. We created this event handler by double-clicking on the button. You don't have to do it that way. Let's go to the code, remove this event handler, and start over again. Actually, let me copy this to the clipboard because I'm going to need this again. There we go. Let's remove this altogether. Go back out to our designer, remove it here, and see how else we could do this. Now, here I am in my XAML, and I want to add a click event handler. I look for the click event, I press Tab, and that brings up IntelliSense that says let's insert a new event handler. I click that, and it creates one for me with a default name. I can either change that name or leave it alone. Let's say I change it. Let's call it Click Handler. There we are. Now if I right-click and choose Navigate to Event Handler, they create the event handler for us and place us right into it. So even though I never had a procedure named Click Handler before, there it is. Okay, well let's say I want to use this one instead. Go back to our code. Let's remove this and try it again. Now we get a drop-down list, new event handler, or any of the procedures in our class that match the appropriate event delegate signature for this event. I'll choose demo button _ click, navigate to the event handler, and now I can paste the code in that was there, and we're right back where we were. Okay, so there are multiple ways to get that event handler hooked up. Before we dig deeper, I want to show a few more tools within Visual Studio. Let's go back to the designer, and a great tool, which won't show much because we haven't gotten very far yet, is the document outline view. This lets you look at the outline and the hierarchy of controls on your form. If you build complex applications, this will be a savior for you to see which of the various bits of your application are where and how they're related to each other. So don't forget about document outline. Sometimes when things are nested deeply or on top of each other, it's the only way to actually select exactly what you want. Actually, it's not the only way. You can also use the Tag Navigator. The Tag Navigator does pretty much the same thing, except it does it by letting you navigate from one control to another in the hierarchy. By clicking on the arrow, you can select the child, then it selects that control in the Properties window and in the XAML designer, so you can modify properties of the control. You'll find the Document Outline window and the Tag Navigator indispensable when you create more complex projects. Although it seems like events in WPF work the same as events in Windows Forms, they don't. One thing that gives it away is the parameter in the event handler. The second parameter is not a standard event args object, it's a routed event args object. What this indicates is there's something different about WPF events. The deal is, events can bubble up to the container of any control, which means you can have the event handled at any level. If you have a button that's within a grid cell, that's within a grid, that's within another grid, you can handle that click event at the control, at the cell, at the grid, at the parent grid, or at the window level. That allows you to write one event handler that can handle events from lots of different controls if that's what you want. The nice part is the code can alter the perception of what the source object was. So at any point, the event handler can change the object that looks like it raised the event, so you get lots of flexibility in terms of who raised the event and who handles the event. The code, however, can always determine the original source of the event and the original event itself. Here's a list of the properties of that routed event args object that you're likely to use. The handled property gets or sets a value that indicates the present state of the event handling for the routed event. In other words, you can use this to determine if the event has been handled yet or not. The original source property gets the original reporting source before any changes to it have been made. You would use this to determine what originally got clicked or changed or touched to cause the event to be raised. The routed event property gets or sets the routed event associated with this routed event args, which means that you can find out the current routed event or you can change the routed event. So the button may raise a click event, you could change it in your code to something else and raise it on up to some other object. The source property gets or sets a reference to the object that raised the event. Now, someone along the chain of events could have modified that, so if you need to know what the original source was, look at the original source property. But this tells you, from your perspective, who raised the event that you're handling in your code. Well, this seems complicated, and you're wondering, why would I ever use this? Let's go back to our example and modify it so you can see how you might, at one point, care about some of these properties in your code. In order to demonstrate routed events, we're going to need to have multiple controls on our form, which means we need this button not to take up all the space on the form. So let's set the width and the height. Now notice how I do this here. I could set them in the Properties window, but I like working in XAML. So I'll just type width and then press Tab. The equals and the quotes go in for me. I'll just type the value and move on. I want height here. So let's do H-E-G. There we go. It works better if it has a space after it. I press Tab and put 100 in there as well. And there's my button. Let's move it out of the way, say here. And now let's make a copy of it. I would like 2 buttons on my application. I press Control-C and Control-V. We now have 2 buttons within our grid. Notice there's a click event handler hookup for this button, but not for this one. That's because when you copy and paste the button, the paste mechanism strips out event handlers because they figure you probably want to hook up individual events for that button. Let me save this. Press F5 to run. Click the buttons. Now this one has an event handler, so we see hello. This one does not, and nothing happens. Okay, that's probably what we expected. But we can handle that event because it's a routed event at the grid level or at the window level. Well, I'll handle it at the window level because the window level has a particular mechanism for handling clicks of any kind of button, even things that don't look like buttons but act like buttons. On my form, the button base.click event handler lets me do that. I press Tab to insert that, and I'll choose demo button underscore click and press Tab. And so now, at the window level, if anything that inherits from button clicks, we'll be able to handle it here by calling that demo button underscore click procedure. Let me run this again. Click this button. There's our alert, and there it is again. Now, why is that? That's because we had a button click event handler and a window level click event handler. Now this one didn't have a click handler before, and now it does at the window level. Well, certainly we don't want 2 clicks for the first button, and I really would like some way to determine which button was clicked in the code. So let's remove this button level click handler and look at this event handler. Now within here, we're handed routed event args E, and you can see that E does provide, in addition to the normal object properties, the 4 properties we looked at already. It's the original source property we're going to use to retrieve a reference to the button that you clicked. Now original source returns an object, so we'll need to cast it as the correct kind of thing, so I can declare the button, and let's cast it and retrieve the result from e.originalSource. So there's our button, and rather than displaying this hello from WPF, I'm going to display hello from the button we clicked. That's the name property of that button. That's what it takes. We need to cast the original source as the kind of object we care about, and then retrieve whatever properties we need. Run this. Click the first button, hello from demo button. Click the second button, hello from button 1. So you can see that we can, in that routed event, determine which object raised the event, and take different action depending on that information.